Audible in the back? Good to go? Okay, thank you. So thank you for the lovely introduction, and thank you to David and Darren for having myself and Helium here at the meetup. We were part of something else that happened at Capital Factory about 2 to 3 months ago, specifically around blockchain. Not so much about the Helium platform, so it's good to be back. My name is Mark Phillips. I run business development and customer success at Helium. How many people had heard of Helium before signing up for this meetup? Cool. And then David kind of got into this when he was asking about what people are hiring for and what kind of jobs and what they're looking for. But I always like to ask what the kind of makeup of the crowd is. So who is doing, we heard embedded development, so people are doing embedded development, actively building IoT products, connected products, at least one person, UI, UX stuff. What else? Anybody specifically, in love with wireless, or in love and then hate, and then in love with wireless, generally?
Love to hate.
Like to hate?
Still in the hate phase.
Love to hate, yeah, it's a very easy thing to love to hate. Cool, okay. Anybody focus on blockchain? One. Okay, cool. Great. So this talk is going to cover a bunch of stuff. It's not going to get wildly technical, but I'm happy to go there either via questions or kind of after the talk. I've also brought Robert Keith here with me, who is one of our lead hardware engineers. So he's very much in the weeds on building all the hardware components I'm going to talk about and a lot of the wireless pieces I'm going to talk about. So I'm going to make some things up and then kick it over to him on the very technical side. And we have to go deep on things like DSPs and PRUs and all that good stuff. Cool, okay. So, the talk will probably run 20, 25 minutes. Happy to take questions during it. And then, let's have some fun. So, a bit on the background of Helium. So, we were founded a long time ago, although we still very much consider ourselves a startup. So, founded in 2013 with a mission to really make a network that is ideal for low cost, long range data. Actually, definitely want to hear more about your use case, but I think we're going to be right in your sweet spot. And we've got a fantastic roster of companies backing us. Sadly, nobody from Austin just yet, but Digital Garage, Munich Re, which is the largest global reinsurance company in the world with some fantastic IoT use cases. Slow Ventures, Google Ventures, SV Angel, First Mark Capital out of New York, Mark Benioff of Salesforce, and Costa Ventures. So we've got a lot of big guns in our corner. And we've raised, I think, 3 rounds of funding, seed A and B, up to end of 2015 was the last time we raised money. So, more importantly, we are here to talk about what Helium sees as this massive problem, which is that it is entirely too hard to connect devices to the internet, still now. Helium was founded in 2013, so 6 years ago at this point, actually. I joined just after we founded, so I've been there for 5 years. And we're still trying to solve the same exact problem that we were funded to solve at the time. And so we've gone through this kind of massive path to get to where we are. So I can talk about the different iterations of our platform, but we started actually with something that looks quite similar to what we have now, just in a lot of different ways. So I'm going to pass this around a little bit later. This is the Helium hotspot. Before it was called a gateway. We've had previous versions of this, and we've improved on it in a ton of ways. But we were founded, again, to start this big public wireless network. And then we got into these use cases where we were working with large companies who were trying to deploy temperature sensors, HVAC systems, smart agriculture, mobility use cases. And we would get into these kind of very small, constrained, successful scenarios, and then hit a wall when people were required to scale up past what would end up being like a local network, right? It can work fine on a factory floor, it might work fine on 10 acres of farm, but when the end customer is required to deploy their own network and kind of maintain it, that's where things fall apart. So what we consistently saw in and out year over year was that the network just wasn't there to suit what the use cases were. So today what we have is a smattering of everything. We've got cellular networks, we've got NB-IoT, we've got narrowband things, we've got LP-WAN technologies, we've got Zigbee and all the 15.4 family, we've got Wi-Fi and Halo and Bluetooth LE and all these crazy things. On the long-range connectivity use case, cellular networks are really trying to pull away. But we're of the opinion that their technology just isn't good enough. We've got a small set of players at telcos who are trying to basically pull people into this world where they control all the connectivity with similar business plans and a closed business model. And about 18 months ago, we went back to the drawing board and said, this is just not going to cut it. We can't make our customers successful. We really have to kind of go all in. And so I'm going to talk about kind of the changes that we made to the platform. So when we look at the sort of devices that need to connect to the internet now and the technology that's required to kind of make them successful, Helium looks at things like, years of battery life. So I forgot what you said your name was, sir.
Paul Corrigan.
Paul, right. So when you're looking at your device that's going to go on a Serena Williams or something, how long do you expect this thing to last in the field?
8 to 12 hours.
Oh, okay, that's not bad.
And then it'd be
Terrible
charged
example.
overnight.
It's a bad example for what I'm going at. But let's say you want to put a temperature sensor in the middle of a field, right? That's going to look at temperature of a field plus soil conditions. You don't want to send anybody out there any more than once every 6 months, 12 months, 18 months if possible. So we're looking for years of battery life on an extremely small battery. We need a tiny form factor. I've got some hardware that I'm going to hand out here. This is the Helium development board. On this development board is the Helium module, which is only about 13 by 13 millimeters. That's literally all you need to build a fully connected device with a processor for sensor applications, and your radio, and your crypto stack, and a nice embedded environment that this guy Robert and the team worked on. 13 by 13 millimeters. That's crazy. We're building things like smart connected caps that go on top of files. So form factor is a massive requirement for these things. Did you have a question?
It's a featherwing, right?
This is a featherwing. This is a development board. Yeah, I'm going to pass this around. This is the Helium featherwing dev board. On this dev board is our module. So this is just made for prototyping or building things in production if they're big enough. People need location tracking without GPS. So who's built a thing that you built something with GPS? Would it be nice if you were not encumbered by GPS?
We have to work in rural areas, so
Yeah.
it would be great if we didn't need GPS, but we need pretty much the accuracy of GPS. We need to be able to work in rural, remote areas.
Right. I had never ridden a scooter before. I live in Boston. We haven't authorized scooters to be on the streets yet. San Francisco has a few. I haven't had a chance to use them yet. I am in love with those things. If you hate them, I apologize. It was one of the greatest trips up and down the street I've ever had. Location data on those things are terrible. And those companies, does anybody work for a scooter company or have looked into the economics of how scooters are functioning and if they're making or losing money? They're not making money just yet.
They're losing money, aren't they?
They are. It's going to get better.
Yeah.
Companies like Helium are going to help with the problem. I'll talk a lot about the tracking use case, but envision a world where you don't need GPS to get very accurate location data off of a 13 by 13 millimeter square. Pretty cool. Miles of range, right? So rural areas. Imagine, for us, one of the use cases I'm going to talk about is a smart agriculture use case. A company called Agulus, which is going into farms in the south.
What company?
Agulus, A-G-U-L-U-S.
Oh, it sounded much like Agulus, which my kid works for.
Nope, not that one.
They're not worth it?
No. So this company builds irrigation monitoring system for non-row cropping farms. So not corn, but things like pecans and peaches. And so they're building wireless infrastructure on top of Helium, and they can deploy one of these to cover 100 square miles, which is pretty massive, right? It's a very small piece of hardware. I'll talk about what it costs and what it takes to build it. But if you've got 10 farms, 10 of these at a cost of $450 US, and you cover the entire thing, pretty good deal. So it needs miles of range, and the network has to be able to support that. And then lastly, we're adamant about the fact that it has to have non-proprietary technology. Every single telco is using things that is encumbered by patents, and they're paying huge royalties to Qualcomm. There's some new LP WAN players. So LP WAN is low power wide area networks for people who aren't as deep in the wireless stuff as we are. So that's that's the Heliums, but that's also the LoRa's and the Sigfoxes of the world and the Weightlesses. And there's 2 or 3 other ones. Everything except for Helium is entirely protected by what looks like a traditional royalty regime. So we don't think that that's the way to do it. We're building a network actively that is made to run without Helium's intervention. Our goal is to build this decentralized wireless network such that we could, if ever we wanted to, kind of walk away from the thing after it's deployed and running, and everybody would be able to continue using it. I'll get into how we're going to do that. So what we're at now is on the cusp of rolling out the Helium network. So it is an open, decentralized, cryptographic wireless network. And for us, this is really the culmination of the last 18 months of rebuilding the platform towards those 5 bullet points that I just talked about. giving you longer battery life, miles of range, non-proprietary technology, GPS-free location, and a tiny form factor. So the Helium network is the embodiment. Actually, Robert and I were down here in Austin to give this talk, but also to work with a few of our customers and early deployers, a few of whom were in this room tonight, and get them up and running on the early version of our network, and really start to get into why Austin's going to be one of the biggest cities for us, which I can also get into. So you're probably asking yourself, how is a company like Helium selling, small pieces of hardware going to cover the world in this crazy new wireless network? So we had one person here familiar with blockchain. Has anybody else read up on it enough to feel dangerous? Okay, so we're building an incentive-built network. So 18 months ago, like I said, we went back to the drawing board and said, we've done thousands of POCs with everybody from startups to Fortune 10 enterprises. And we kept seeing this theme that unless the network were to exist, we couldn't succeed. So how do we build a massive network without having tens of billions of dollars a year spent on capital expenses to put towers up on every single building, maintain those towers, expand our tower space? So the answer for us was to come up with a mechanism by which we could incentivize people to build network for us. And so we said, oh, well, this blockchain thing is kind of crazy. Let's think about it for a few minutes. And we did this, and we laughed at it, and we kind of threw it out the window. And we came back to it 3 or 4 other times, and then eventually somebody wrote a white paper internally on this. If you go to, there's going to be links up at the end of this, but at helium.com, we've got a link to our white paper, which lays out all the technology that kind of underpins this. That's version 50 of the white paper. We went through a lot of these. And so we came up with this system whereby we incentivize you, and I hope some or all of you in this room will take part in this. We incentivize consumers. It could be a consumer who doesn't care about actual IoT data, or it could be somebody who actually is deploying devices and wants to create coverage for them. One of our customers in Austin, Stay Alfred, is doing that. Deploy Helium hotspots. So here. And in exchange for deploying that, there's a blockchain that runs on these hotspots and also runs in the Helium cloud infrastructure and compensates people for running that. And the beautiful part about this, and this talk wasn't really to get too deep into the blockchain, but I'm kind of happy to do it. As the network gets larger, the network actually gets stronger because the blockchain running on these hotspots is responsible for actually verifying the integrity of the network that surrounds it geographically. So, one of these, we'll go to the hotspot picture. So we'll get into some specs on the Helium hotspot. So, had anybody read anything about this before? I know a few people have looked at Helium. Okay, so this is, I don't know what version of this. I mean, this is version 5 of this specific unit, but we've had probably 20 different hardware units that look somewhat like this that do kind of wireless coverage. We used to be in anybody ever worked with like 802.15.4? Anything? Yeah. So the first version of our gateway, we call it the gateway, was built on 802.15.4, but that sort of wireless range was not going to cut it for the sort of application that we needed. So we went back to the drawing board, designed this new hotspot, and we designed it around a radio module. I'm going to pass this around the room. Actually, I can pass this around after one of this. So this is the development board. I'm sorry, I told you I wouldn't walk around, but I did. So that's the development board. In the middle, there's something called the TI-1352P, which is a sub-gigahertz wireless transceiver with an M4 processor and a lot of other stuff, as the RF hardware engineer says. So the center module is all you need to connect to a network built of these. And so the protocol that uses to transmit data is a new protocol that we're going to be releasing in the next couple months, which uses a handful of open known modulation techniques for sending data using publicly accessible sub-gigahertz wireless spectrum. So we built this hotspot to be 2 things in parallel, a blockchain miner and a wireless access point. So on the blockchain mining front, this runs a Helium blockchain and is constantly performing mining operations, pumping transactions into blocks and pushing them out. And again, I can go into the specifics of the blockchain, but it might just kind of take us on divergence here. And then the wireless piece is built on a software-defined radio. Anybody ever done any work with software-defined radios or SDRs? Yeah, they're black magic as far as I'm concerned. He's laughing and he knows about signal processing. This guy is deep in it as well. It is a fantastical sort of thing that can sit there and ingest a massive amount of, in our case, RF data. And then on the other side of this pipeline, it shows up as packets, right? And we push those packets over a backhaul back to the internet. So we've built a software-defined radio that is built on a very cheap component from a company called Line Micro. There's a ton of innovation in this hotspot. And it's capable of processing roughly 300,000 packets per hour for one of these things. So it uses narrow band channels between 902 and 927 megahertz, which is part of the ISM band, and that's in the United States. And this thing can just process a stupid amount of sensor data, essentially. That's all you really need to take away from that, for a very cheap price. So these are going to go on sale in May. I'm going to talk about our roadmap. Austin is our launch city, so we love Austin for a lot of reasons. We needed a city where we were likely to find people who were interested in IoT, in crypto, the blockchain, and who would want to be incentivized to put a $400 piece of hardware in their window and create wireless coverage. Austin was one of those cities for a variety of reasons. Question?
Yes. Is the router a full node or a light client?
It's lighter. It's not really a full node. So it's built on a Satara. So it's a dual core ARM, and then it's got about 4 gigs of storage. Yeah. So it's not big by any means. And so we have to do a lot of work to only keep the smallest amount of data on this thing. So there's a bunch of full nodes that run on the cloud side that keep the full blockchain up and running.
So what are you guys using as a data layer for managing the data on the device?
On this? I mean, it's a Linux-based OS, and
That's pretty broad.
So like the database, the data structure that you're using to store and manage blockchain data as a light client on the router. Like, is it like a SQLite? Is it?
No. So you can look at our repos, and I didn't build any of that.
Okay.
So I don't really know the best answer for that.
we can follow up after this, but we're using an embedded database called RocksDB.
Oh, RocksDB.
Yeah.
Okay.
And so we bounce between that and the other one that was at Basho when I worked at Basho. Let's talk about it after. But RocksDB and Andrew's going to kill me. I was there when he wrote the thing. Anyways, it's essentially an embedded key value store. That's all it is. Yeah. Okay, so let's talk a little bit more about how we reward hotspot operators or hosts, that we call them. So hopefully when people leave here, they're going to be very motivated to go and register to be on the hotspot waitlist. What that will do is make sure that you get notified when these things are available to go on sale, which again should be mid to end of May. So the hotspot again is doing 2 very interesting things at the same time. It's being a blockchain miner for the Helium blockchain. And the Helium blockchain is something that we wrote from scratch specifically for devices and sensors in the real world. I can again go into all the specifics of why we went with something off the brand new versus off the shelf, like Ethereum or the Bitcoin blockchain or name your own blockchain. But we needed something that would specifically let us push something useful back into the network as the blockchain was doing its job. So with something like Bitcoin, you're just trying to solve a puzzle using hashes. And, you're keeping time, and then every 10 minutes you pop out a new block. You generate you match the nonce, and then you pop out a new block. For us, we didn't want that, and that wasn't anything useful for us. So for us, what we did is we built this system called proof of coverage. And so proof of coverage dictates that hotspot 1 can sit in the same geographic area, or not in the same geographic area as hotspots 2 through N, and then constantly verify that those hotspots are actually providing valid network coverage. And so over time, we start to get a very good view of the network and the robustness of the network. And we call this proof of coverage. And so hotspots are constantly submitting proofs. And so they rise or fall in this kind of list of quality scores that we have across all these hotspots, and that makes them more likely or less likely to pull in mining rewards, or makes them more or less likely to be basically paid off for them managing the network on our behalf. So the hotspots are producing a utility token that is native to the Helium platform. And hotspot operators, I'm going to attempt the demo gods and do a live demo in a second. Manage all this through a wallet app on iOS or Android. We have a desktop wallet that'll follow that too. So, those are kind of the tenets of the network. I always like to pause here and see if anybody has any questions because I kind of covered a lot there. But we're starting the back.
What development languages am I going to be writing?
Yeah, so that is built on an environment called Talk, T-O-C-K, which is an open source project out of Berkeley. Robert can talk more about this. But you can write, what is it? C and
C, C++, Rust.
yeah, so C,
Python, I guess.
C, C++, and I guess Rust would be the native languages you write, and then we'll wrap that with SDKs for things like Arduino, Raspberry Pi, Embed, things like that.
No C#.
Not embedded.
Not Embed. No.
It's happening.
Is that a thing? Are people doing it?
Yeah, totally.
Really? Okay.
C# on a Raspberry Pi.
Yeah?
I've done it. Presented on it.
That sounds terrible.
It's actually fun.
Okay. And you had a question?
Yeah, I have two actually.
Yeah.
One of them is you said you're selling these for $4.95. How long or what is the amount of data that I need to transfer or connection I need to make to recover that $4.95 investment?
Oh, that's a good question.
And the second part of the question is, you said these are going to be connected to the internet that I have at home from the cable company. What about the contracts or the terms of conditions that these cable providers are having for me not to pass the internet access that I have, like tethering or
Sure.
basically broadcasting to third parties,
Yeah.
which will eventually this will.
Yeah, so the two questions are, what is the ROI on the hotspot? How long will it take for me to get paid back my $450 US? And the second question is, you're going to be using my backhaul. Are we going to piss off the ISPs and the telcos who are funneling this data? The first question is one that I can't answer for you because our blockchain is not live yet. When the blockchain is live, the token becomes a real thing, and then when the token becomes a real thing, there's a price attached to it in the open market. We don't know what the price will be for the token. I can get into how traffic is kind of accounted for from devices to the platform, and then kind of talk about how that might amount to tokens that you end up bringing in. It's a much longer conversation. But I can't put a value on the token because it's not public. That's the short answer. Legally, I also can't just say, hey, it's a cash machine, because it's something that does real work, and it will produce a token that has some value, and on some exchanges you'll be able to exchange it. That's the short answer. That said, our models are very aggressive. So in the first 6 to 12 months, the first people on the network will be getting paid back very aggressively. But we should talk more about that. One second. And the second question was, what's happening with the backhaul? Are we going to piss off the providers? So this model has 3 backhaul methods: Wi-Fi, Ethernet, and cellular. Future models will have cellular only. Some will have Wi-Fi and Ethernet. For cellular, we're using an actual cellular provider or an MVNO, mobile virtual network operator, on top of that, and we bundle those fees in to the cost of the hotspot. So that's taken care of. On the Ethernet and Wi-Fi side, we would view it as a good problem if the ISPs started to get upset at data passing through the network. I don't have any direct counter to how to get around the contractual language. The amount of data being passed through a hotspot, even at a huge scale, let's say we have 100 hotspots here in Austin and 50,000 devices, it's going to be negligible, compared to the other traffic being pushed through your Wi-Fi network. So we're just kind of planning on tackling that problem as we come to it. But again, if you see things in the news about Comcast not being happy about all the hotspots using the network, we've done reasonably well, at least in the beginning. So.
Yeah, in New York, because there are some companies that just started, and I think they first started in France. When they build a mesh network out of the routers, they actually send to the customers, etc., like that. And they're running into these kind of problems. And one of the other things that I might mention is when I started my own cell phone company, it was a telecom company, and I was MVNO. And one of the things that the telecom companies, the 4B telecom company says is like, we don't want to be the dummy pipeline for the data. So they have, it doesn't matter, regardless of how much of the data actually goes through their network, they are very keen on.
So the smart ones want to work with us. So we've talked to everybody that might have a problem with data passing through their network as a form of backhaul. Some are very excited by the idea of Helium, some view it as a crazy competitive threat. Some are somewhere in between. I suspect what will happen is a few will gravitate towards us and work with us, and then others will be left in the dust. That's the supposition. A few more, then I'll move on and we can do questions after. Sorry.
Yeah, so it sounds like your economic model then is built on how much traffic goes through the hotspot that I put in my place, right?
Not entirely. There's other mechanisms through which the hotspot operators could compensate.
So if being in central Austin versus being out in the sticks.
Right, so early on, we will be, the mining rewards will favor people who are simply deploying hotspots versus those who are routing more traffic. So that compensates for the idea that early on in the network, there's not a ton of devices actually sending things. And then further on down the road, we kind of start to move towards compensating more for device traffic versus we do for mining rewards. So we have things built into the distribution of the difference to account for that.
What frequency band are you in, and what are you doing to manage that spectrum?
Yeah, so we use 902 over the
ISM?
Yeah, ISM. Yeah, so in the ISM, we'll be in the ISM globally. We're starting in the United States and Canada, so we're doing FCC and IC certification currently. And then, I don't know, what are we doing to manage the spectrum?
A lot.
We're doing a lot to manage the spectrum, according to the wireless guy in the back. Yeah, we can talk more about that afterwards.
Secret sauce.
One more and then we're going to move on.
Okay, got a few questions.
Okay.
One is around, have you guys heard of Nodal as a possible competitor?
Yes.
Yes. Two, do you guys, is Helium only restricted to the routers that you sell, or do you plan to include like third-party routers or even like other IoT devices like phones
Yeah.
to contribute and pass internet? Yeah?
Yeah, so I haven't looked at Nodal in a while. There's a handful of companies like that.
Yeah.
There's Nodal, there's Althea, there's a couple other ones. I don't know the specifics. We don't plan on being in the hardware business for too long. So right now we make hotspots and we make modules. We will actively look to offload the production of that to manufacturers or work with companies that might build a Wi-Fi AP that happens to have the Helium components built into it. So yeah, we'll move that and kind of partner with companies that can help us gain those distribution mechanisms.
Okay.
Cool. Okay, let's move on to some use cases. So I want to talk a bit more about what people are using the network for and what we think they're going to use the network for. And I always like to kind of bring it home with one very poignant story. So what we're really driving at here is trying to build an infrastructure layer that can be used for connected applications that were never possible before. Most of you will probably remember the Camp Fire that ravaged Northern California in like November of last year. So 17 days, it burned about 150,000 acres, which is over 220 square miles. 83 people died. And imagine how much that loss could have been prevented had that area in Northern California been outfitted with sensors that could have given people insight into when this was going to happen sooner. So sprinkle heat sensors over the forest. Add other mechanisms to pull data from inside of an environment like this. And then, imagine doing that on a cellular network. There were stories about how, this isn't directly related to Helium, but some of the first responders in this campfire situation, Verizon was throttling their data, which is just, even if it was a mistake, absolutely terrible. But in our opinion, sensors that sense wildfires should not have cellular data plans. That's not a thing that needs to happen. There needs to be a better network for this. So on the use case side, we think that one of the biggest things for Helium is going to be tracking and tracing. So we think we can quickly get to a place where we can go to somebody who needs to track something and say, for an all-in cost of $2 plus pennies a year for connectivity, you can track anything where the Helium network exists. So that's a big caveat, right? We have to build a network out, and if it doesn't exist yet, you can't do any tracking. But we think we can pretty quickly build coverage. So this tracking and tracing use case, and I'll talk about some of the implications for mobility, is where we really think we're going to shine. And our early engagements with the new network technology and our early engagements with customers, large and small, are already starting to bear this out. and we're actively building on top of the Helium platform. We haven't talked much about revenue models for Helium Inc., the business. We don't really need to get into that, but we're actively building ways to integrate all this data into ERP systems, CRM applications. We have a tracking application which I'll show people in a bit. But I'm going to keep coming back to this tracking and tracing application because I think this is really where we're going to get a foothold. So I talked about being very excited about scooters. So scooter companies have a very big problem. They lose bikes all the time, or scooters rather, all the time. Goes for bikes as well. In the mobility space for smaller assets that are cheaper than say cars. A huge problem is that they lose these things well before their expected profitability date. So if something costs you $1,000 split in the field and you make $100 a day, it only lasts 9 days, you're losing $100 every time that goes out into the field. So Helium is working with a few mobility providers to really help them change the game on unit economics. And so they're very excited about the idea that they can either replace, but more likely retrofit their fleet with, who's got the module in their hand that's out there floating? So that was a plan, we did it. So retrofit this onto a scooter in such a way that it's kind of hard for someone to see or pull off, and start pulling very accurate location data from that scooter past the life of the main battery on the scooter itself. So the big problem with these is that they disappear, the battery dies, there's a GPS ping from a day and a half ago, you send somebody out to find the scooter and it's gone. That's $3,000, $4,000, $5,000 worth of inventory down the drain. So for every day that we can extend the life of one of these, we can go to a scooter company and say, hey, this scooter will be more profitable. And so all happens without a cellular data plan. It's all a retrofit, and it happens for a very cheap hardware cost and very cheap connectivity. So I'm very excited about the location capabilities. And so this is a chunk of data from one of the location tracking tests that we did a couple weeks ago in San Francisco. Were you riding the scooter?
No.
No. You might. So
That's just right.
what's that?
I was just thinking of the hills.
Yeah. So that's right. Let's go through the location. So this is using the Helium network in San Francisco. So we've got a test network in San Francisco running with these. We've got 10 maybe, not a ton. At the time, I think we had less than 10. And we built a device that looks like what Robert's got over here, which we're going to demo in a second. And we just pulled some fantastic real-time tracking data off of the scooter. So this is a screenshot from more or less the application that we have on top of the platform that is made for location data. But this is data coming from the Helium network, no cellular involved, giving you fine-grained location, which is pretty cool. Okay, who has a pet? Anybody ever lost their pet? No? Good, excellent. So we're working with Petco and a company called CBC to build a pet tracker, location tracker. So, a very cheap, inexpensive, very kind of stylish thing that sits on a dog or a cat collar and can be made to tell you the location of your prized possession once, twice, 5 times a day. And why you use Helium for this is quite simple. We don't, we're not going to require a costly cellular plan. The cost of hardware is orders of magnitude, 1 order of magnitude less than what you would need for a cellular module plus a GPS. And the development experience is miles away from what you would need on there from the kind of pain you'd have to suffer on the cellular side.
So I guess the location is all triangulation?
It is, yeah. So there's one caveat to the location. So I didn't talk about the location specifically. So let me go back to, I guess this picture here. So this location was actually done using the Helium network, but with the GPS module on this. So the way that the location works specifically is something called TDOA, or time difference over the air. And so when we get density of these in a given geographical area, so in San Francisco, for example, when we get 50 of these, or in Austin, when we get 20 or 30 of these, we can actually start to take data coming off of these And because the software-defined radio is built such that we can pull nanosecond level timestamps off of the device, we can then triangulate or trilaterate between 2, 5, 10, 15 hotspots and get a very accurate location. So down to like 3 or 4 meters. But that's very good density, excellent saturation of the Helium network. In the meantime, what we do is we still rip out the cellular network, but we put a GPS module on the back of it. So you essentially get GPS data for free off of the Helium network without requiring the cellular. So it's a bit of a stopgap measure until we have the the network coverage in place to do the location. But yeah, it is essentially triangulation. Question?
Have you guys talked to Spin?
Spin? No, I don't know Spin.
I would recommend talking to Spin.
Okay.
Scooter company, because they actually built their own crypto-based incentive protocol for their scooter network. They just started deploying. They're San Francisco-based. But they just started deploying in Austin. They've got like the orange logo, it's a Spin on it.
Okay, that's good. Spin.
Spin.
Yeah.
It's just Spin. Yeah,
Cool.
I would recommend talking to them because they're already crypto-focused.
Cool. Yeah, we'll check them out. Okay.
I could probably help you guys with an intro after this, actually.
Yeah, thank you. We should talk. Okay. So, drug companies have a very huge problem. They manufacture these expensive, very valuable, and very precious medications for terrible things like cancer. They put them in a vial, they keep it in a climate-controlled truck, and then they fire it across the country. Most of the time it makes it to its end location, which is a doctor's office or a hospital. In between, it stops at a bunch of different distribution facilities, gets on trucks, gets off trucks. Sometimes these trucks disappear. Sometimes these drugs are counterfeited and they show up somewhere else. So Helium is actively working with Capgemini, which is a big consulting company, and one of their pharmaceutical clients to build a smart cap. So they came to us and said, we have this massive problem. I've got a $5,000 unit piece of inventory. I send hundreds of thousands of these things across the country every year. I need to know where that thing is in real time. So we said, great, we can take our 13 by 13 module. We can build that into a smart cap with a very small battery. And we can put a few other sensors, temperature and tilt essentially to know when it's been knocked over. And we can do it for a unit cost that's in the tens of dollars. And for a data cost, which is probably 25 cents a year. So we're building that actively now. And this is a use case that would never be possible on pretty much anything else. You can't do this in cellular. And the size of the GPS module itself is bigger than the entire cap. And so, back to, I think you had asked, or we were talking earlier about how the network is required for location to be possible. Obviously, the network has to be required for people to move things across the country on Helium. So we're actively working with them to kind of plot a map and get their partners involved in deploying hotspots. It's kind of a common theme. People see the network as so valuable that they want to get their components of their infrastructure involved. So, we're working with a outdoor sports equipment manufacturer that's got a bunch of local retailers. They want to start tracking all of their high-value assets on Helium. And they're happy to give a hotspot to their distributors that are in cities and say, hey, put this in your window, we're using it for your application, and off we go. So we feel we can kind of build a network that way. But people are seeing this as so compelling that they want to help us build a network. And then lastly, I'm going to wrap this up here in a second. So I mentioned this company, Agulus, not your son's company, which is close to eat Agulus. So they build monitoring and optimization systems for non-row cropping farms. They specifically build a controller, so it's this big. It's got a bunch of sensing inputs, talks to a bunch of things in the field, and they use Helium to back all the data. And they set up networks. They ingest data, and then they kind of iterate on models for how the irrigation systems are supposed to work. And so this really makes really good use of Helium's ability to create coverage very quickly and give them a small form factor to deploy into an environment where they don't have to touch the sensor for a while. Okay, so that's some use cases. I'm going to talk a bit about our progress and our roadmap, and then we'll kind of wrap it up. So we've had a test network running since the middle of Q4 last year, so roughly November. We've got coverage, where coverage is some number of hotspots, creating coverage, in about 60 plus cities. A lot of those are in the Bay Area, and there's New York, there's Boston, there's Chicago, there's Austin, so cities like that. If you go to helium.com/waitlist, you should sign up to get on the waitlist for a hotspot. We've got over 1 million hotspots worth of waitlist interest, which is ridiculous. Helium itself as a company has done thousands of POCs to date. And we were founded in 2013. We've been through every single possible deployment scenario with companies large and small, and we're pushing all this back into the platform to make it easier to build. And then Hotspot GA, and we'll take this into the roadmap. So our roadmap looks like this. Sorry for the, I guess it's bigger up here. So we're launching in Austin. We love Austin. We think there's people here that want to deploy hotspots. We've got good data on that. And we actually have a lot of customers that are ready to go in Austin. And we're pushing as many pilots into Austin as we can because coverage is going to be here earlier than most cities. So everyone here is on the front of it.
Does that mean Austin's going to jump ahead of your million people waiting on the hotspot list?
We will be putting early hotspots into, not from the waiting list. We've got a set number of hotspots allocated already.
Okay.
Yeah. You say that like it's a bad thing for an Austin local to do.
No. I'm actually, I got some wheels turning.
Okay. So network launch here in Austin in May. The Helium blockchain mainnet is going to go live. So mainnet is basically when we kick the test network into actual production, and we really can't change much. Meaning the blockchain is running, Genesis block has been mined, things are going, and it's exciting and scary at the same time. So at that point, the Helium Atom token becomes a thing. This is back to your question about the value of kind of what ends up being captured by a hotspot operator. Then we start to see how quickly the payback periods are. We will be doing the first national hotspot sale in May as well. So focus on Austin to get the network live here, to get our use cases off the ground, and then we're doing a public sale. That's when that 1 million plus waitlist quantity comes in, and we anticipate we'll sell through the first run, which is going to be in between 5,000 and 10,000 units relatively quickly. And then we also have beta customers that are being onboarded here in Austin. Robert and I were here meeting with one of our customers today that's doing in-building sensing for sound and motion for short-term real estate. And we've got a bunch of other customers that are pushing into Austin actively. So that's me. In June, I passed around this thing. So we're going to be producing, I've got a bigger picture here. We'll have these available. So this is the Helium Feather prototyping module, this is actually shown, what's on top there, Robert? So there's a GPS board on top of this. But that's the prototyping module that will be available. And again, that just wraps the actual production wireless module, which is required. And then Q4, we do the official US network launch. So that's basically where we take all the coverage that we've produced from that hotspot sale in May and wrap it into a formal network launch. So we're roughly targeting the football cities in the United States. So if there's a football team in or kind of near a city, that's roughly where the network rollout is kind of targeted. And then we'll also start to release a bunch of the components of the network open source. So we didn't touch on this too much, but part of the real vision for this is that the network can be built and kind of grow on its own. So there'll be a foundation that manages all the IP, so the wireless protocol, the blockchain itself, all the schematics and the hardware for the module itself. Most of the blockchain or the hotspot component. We'll start to release this in Q4, and we'll kind of continue that journey. So, yeah, that's all I got for you. My name is Mark. Again, this was Robert. And if you want to get on the hotspot waitlist, it's helium.com/waitlist. The white paper is whitepaper.helium.com. Don't come find me because it's not behind HTTPS. I can't help you there. That's just the white paper. GitHub.com/Helium. We've already got a bunch of code already available, specifically some of the RTOS that runs on this and some of the development kits. And then Twitter.com/Helium is on Twitter. So thank you very much for your time. I appreciate you coming out.